Hello, just going through example number 3 here. So an application of periodic functions. So this time we've got a coast function, and we've got a piston in an engine. So a piston in an engine, what that does, so inside your engine, I'm not sure if you know this or not, but there's these things called cylinders. And let's say it was a V6. So V6 would have 6 of these cylinders. Inside the cylinder, you have these things called pistons, and there's some rings on them. And they are connected to the crankshaft by this connecting rod. Not that any of this is really important, but so they're connected to a rod there. So what it's saying here is y is the distance in centimeters from the crankshaft. So y would be the distance from the top of the piston to the crankshaft. So that would be y. And t is time in seconds. So this inside the cylinder is going to move up and down, and we're always measuring the distance from the crankshaft. So in here, with how an engine works, I guess while we're talking about it, the gasoline air mixture would be here. As the spark plug fires it, it pushes it down. That's where the power for an engine comes from. So first thing we're asked to do is find the period of the motion. So the period is always equal to 180 over k. So in this case, it would be 180 over k value is 9,000. So that would be equal to 180 divided by 9,000, 0.02, and that would be seconds. So what it means is that's the period, that's the time it takes for the piston to go all the way from the top down to the bottom and back to the top again. So that's going to take 0.02 seconds. So it moves pretty quick. In part B, we're asked to find the maximum, minimum, and amplitude. So really quickly, the first one I can get from the equation is the amplitude. So the amplitude will be equal to the A value. So in this case, our A value is 15. It's been stretched vertically by a factor of 15. So the amplitude is 15, and that would be centimeters. Next, I need to find the maximum and minimum. So what I'm going to do is draw a little sketch. So here is X and Y axis. I know that from my C value, the whole thing is shifted up 18 centimeters. So I'm going to put a line here representing that. So that's 18 centimeters. And I know that from this 18, the distance between here and the maximum has got to be 15 because that's the amplitude. So up to here, that's going to be 18 plus 15, which is 33. Same thing happens at the bottom. From here down to the minimum will be 15. So 18 minus 15 will give me 3. So if I draw a quick sketch here of something like that, so I can tell from this, the maximum is 33, the minimum is 3. So the max is equal to 33 centimeters, and the minimum is equal to 3 centimeters. And then for part C, we're asked to find the vertical position of the piston at t equals 1 over 20 seconds. So we want to find the y value, and I'm going to let t equal 1 over 20. So y will be equal to 15 cos 9,000 times 1 over 20 plus 18. So on your calculator, it's going to be like bed mass. The cos would be kind of like an exponent in bed mass. Bed mass doesn't really account for trig, but it would be kind of like that. So I'm going to do this in a couple steps. So first off, I'm going to go 9,000 times a half, or 9,000 divided by 2, and I'm going to get 15 cos. I think I said divided by 2, but I'm going to divide it by 20. So 9,000 times 1 over 20. 18. So I'm going to work this part out first, is what I'm saying. I didn't do anything in that step, but that's okay. 9,000 divided by 20. 450, so it'll be 15 cos 450 plus 18. Then what I'm going to do is I'm going to work all of that out. So 15 times cos 450 plus 18. And it works out to be 18. So the vertical position at 1 over 20 seconds is 18 centimeters. So right there, 4 centimeters. At 1 over 20 seconds is 18 centimeters. Okay, I hope that makes sense. There you go.